I've been working on the Smartwatch project a whole lot over the past few weeks. I'm just about done. I have the watch enclosure mostly done. I need to do a little bit of tweaking and some spray painting, but it's just about there. I'm done designing most of the electronics, and I have the logic board designed, assembled, and completed, and most of the firmware is working too. There's just one thing that doesn't quite work yet, but let's rewind a little first. A couple weeks ago, I got a new 3D printer and totally fell in love with it. Honestly, I might have a problem. It kind of makes me wish I got into 3D printing sooner. It's really awesome being able to design something on my computer and then have it in my hands like an hour or two later. I spent about a week just going through a bunch of different prototypes and revisions, getting it just the way I wanted. There were 3 major things I learned along the way. So early on, I couldn't help but feel like the watch was protruding off my arm in kind of a weird way. I wasn't exactly sure why that was, so I compared it to a real watch. When I looked at a real watch, I saw that it curved a little near the ends to make it sit more naturally around the arm. One of the other major tweaks that happened along the way was that my design's made of 2 separate parts that snap together. There's nothing wrong with doing this, but I wasn't being discreet about how the 2 halves are connected at all, so you can see the joining line right down the middle. I honestly should have noticed it way sooner, but it was a quick fix once I realized. The other major thing that I learned was that tolerances are a real thing with 3D printers. When you print a part, it ends up being a little bit thicker than you actually designed, so if you don't account for that, things aren't going to fit properly. I accidentally made a hole a little too small, and I forced a screen into there and ended up breaking it. I had another screen, so it was okay, but could have been a real setback. So even though I'm really happy with how things turned out, there are 2 things that I'd like to improve in the future designs. The first thing is that it's not actually a circle. I was hoping for my design to look a little bit more like what the OnePlus watch or something like that looks like. Basically a circle with 2 little tabs at the top and bottom for the watch strap to connect to. So the only reason I can't do this is because my screen actually has a notch at the bottom, which I didn't notice at first. And so there's no easy way for me to fix this without switching out the screen entirely, so it's a problem for future me. The other thing is my watch is still a bit of a chunky boy. It's still about the same thickness as most commercial smartwatches, but that's not good enough for me. I know I can do better, I know I can get it thinner, I just need to make some redesigns. Again, I really want to get the smartwatch up and running, so this is kind of a lower priority. Problem for future me again. There's still a little bit more tweaking to do. For example, I need standoffs for the logic board to sit onto, but apart from that, I'm basically good to go. Just need sanding and spray painting. Moving on to the electronics in this logic board, I actually don't have all the circuits tested properly. There's still some stuff that doesn't work. All the important stuff works, so I should be able to test it just fine, but there's some things that don't work, for instance, wireless charging. And getting the wireless charger to work has been surprisingly challenging. It's supposed to be really straightforward and really easy, but I'm on my second prototype now and it still doesn't work. So the issue I had with the first board was because I was a total clown. There's a calculation you're supposed to do to tune some parts on the charger to make sure that it resonates at the right frequency. So we can think of the charger kind of like a tuning fork. It's listening for a certain frequency, and if it hears that frequency, it's going to start resonating. These chargers output a fixed-ish frequency, so it's kind of up to me to make sure that the charger is actually listening for that frequency, and I managed to mess it up. Fortunately, I didn't mess it up by too much, so if I got the charger lined up just right, it would start to transfer some power, but even then it wasn't a whole lot. Another thing I didn't realize until later was that these capacitors have to be a certain size in order to be able to transfer enough power. It wasn't the end of the world, but it also would affect performance. So there were a total of 2 issues that I need to fix, the part sizes and the part values. I decided to just go ahead and make a new board with corrected part sizes on and move the chip from one board over to the other, which in hindsight was kind of a bad idea. So what I really should have done was that I should have made sure that the part values were actually incorrect by switching out the part values on the original board first before moving stuff over to a new board with corrected part sizes. This would have helped make sure my theory was right before I introduced other potential points of failure. And guess what? It didn't work. I was getting nothing at the output. Honestly, I was kind of scratching my head wondering why it wasn't working. It was basically the same circuit as the original prototype, so there was no reason it shouldn't work, but it still wasn't working. So after a bunch of times staring at data sheets and scope captures, I think I have it figured out. If we look at the block diagram, we can see what's going on inside this little chip. So there's 2 separate parts happening here, and it's kind of similar to how a wall charger works. The first thing it does is this thing called rectification. It takes power coming from the charging coil, which is AC power, and it converts it to DC using a
full bridge rectifier.
Well, kind of. I'm not going to get too into it, but it uses FETs instead of diodes. If you know how DC motor controllers work, it's basically the same thing, but it's running it in reverse. And so we can measure the output of the rectifier to make sure that we're actually seeing something there. And everything looks perfectly normal there. And that kind of makes sense given that the charging pad is lighting up, telling me that it's transferring power. We can see that between the rectified output and the actual output, there's this little block called a linear regulator. And we can kind of treat it like an on or off switch. As long as there's no crazy fault, like drawing too much power or something, it should allow current to flow. And so this chip actually has a pin telling me whether or not the output should be on. And if I hook up an LED to this pin, it tells me that the output is on, which doesn't make sense because I'm not seeing anything at the output. So the only thing that makes sense to me is that the switch itself must be broken. Basically, the chip is telling it to turn on, and because I'm not drawing any or doing anything crazy like drawing a lot of power, because I can't, it thinks everything's okay. So basically it's telling me that it's on, but it's not really on. It's kind of like if I pop the breakers to my room lights and I tried to turn on the switch in my room. The switch would be telling me that the lights are on, and it thinks the lights are on because it's doing its job. But there's another element in the system that is broken, and it's unable to tell that it's broken. So it can't really tell me that my lights aren't working. And I think I killed this part when I pulled the chip off one board and put it onto another. This is actually pretty common, especially if you're using hot air stations, because these chips don't like getting hot for too long. So if you heat them up a bunch of times and let them cool down a bunch of times, they'll just get angry and give up. Anyways, lesson learned. Be smarter about testing next time. All of this is to say that I don't actually know if the wireless charging works, and I am going to test it before actually hooking up to the battery. But I'm kind of going in blind, and if it ends up not working, then I won't be able to charge with this board, which will be kind of awkward. Anytime I do need a charge, I'll basically have to pop open the back and disconnect the battery and plug it into a charger, which is not the best solution. Moving on to the actual logic board, I actually ended up designing this in about a day. It was a little rushed, but not too crazy. So most of the schematics were copied and pasted from the original prototype, so there wasn't a whole lot to do there. The part that I rushed the most is called placement or floor planning. It's how you decide where parts physically go on the board, and I really should have spent a little bit longer with this than I did. The step after this is called routing, where you physically connect all the parts on the board to one another, and it took me about 6 hours to properly route it. And it would have really sucked if I got 6 hours into my design and realized there wasn't enough room to actually route everything, and I had to start over. So this is one of the more complicated boards I've done in a while, mainly as a function of how dense it is. I've never really had to do too much stuff with parts on both sides. As a result, I just kind of got too overconfident and assumed that'd be easier than it did, and I didn't give the initial floor planning / placement the time it deserved. I ended up being really lucky and ended up working out, but it could have turned out a lot worse than it did. Needless to say, there's still a bunch of room for improvement. I think it's still a pretty decent first shot. I'm really happy with how things turned out, but there's definitely still a lot of room to improve. It ended up looking pretty quality, if you ask me. Anyways, that's about it for this video. This should be the second last video for the Smartwatch series, for now at least. I got a whole bunch of other cool stuff lined up. The next video after this should be about lasers, so stay tuned for that.